Hello and greetings to everyone. Today we are going to start with topic 9. Topic 9, abbreviated as T subscript 9, which is arithmetic processes. So this is the topic we are going to treat today. Okay, when we talk of arithmetic processes, this is a branch of maths that uses arithmetic operations to solve real-life problems. For example, a man buys a plot for 3 million francs CFA, which is approximately $5,000, and sells it for 5 million francs CFA, which is approximately $8,340. How much did the man make as profit? In this case, for us to get the profit the man made, we are going to subtract the cost price, that is 3 million francs CFA, from the selling price of the plot, which is 5 million francs CFA. You see that in this case, in getting the profit the man made, we are going to carry out subtraction. Now let's write this down under this topic, under arithmetic processes. Under arithmetic processes, we are going to treat the following. We're going to treat the following. The first one, we are going to treat the ratios. The ratios. Next one, we are going to treat the scales. After scales, we are going to treat the percentages. After percentages, we are going to treat the proportions. After proportions, we are going to treat the speed. The speed, we are going to treat rates. After rates, the axis. After taxes, error. Error, we treat profit and loss. Next, we are going to treat simple interest. After simple interest, we are going to treat compound interest. And currency exchange. We are going to treat currency exchange too. And many others. So there are many other things on the arithmetic processes, but these are the ones we are going to treat. Now we are going to take the first one, I, which is ratios. This is the first one, I. Take this down. When a quantity of the same type is shared in a particular order, the quantity is said to be rationalized. That means when you share a given quantity in a particular order, the quantity is said to be rationalized or shared in a ratio. So underline rationalize, shared in a ratio, underline it too. It is very important. Now let's write down the definition of a ratio. A ratio is when two or more quantities of the same kind are compared or a ratio is made or formed when a quantity is shared into two or more parts in a particular order. So this is the definition of a ratio. A ratio is when two or more quantities of the same kind are compared, or a ratio is formed when a quantity is shared into two or more parts. For example, 10 oranges can be shared to two persons, with the first person taking 4 oranges and the second person taking 6 oranges. The same 10 oranges can be shared to two persons, with the first person taking 2 oranges and the second person taking 8 oranges. So those are examples of ratios. Now we are going to take note of the following. Take note of the following. Take note of the following when dealing with ratios. When dealing with ratios, we take note of the following. The first one, the quantities are of the same kind. So we only take ratios of quantities of the same kind. Next, 2i, the units of the quantities must be the same. For example, we can take a ratio of distance, of which the first component can be given in centimeters and the second component in kilometers. So for us to easily compare them, we are going to make the units to be the same, either by changing from centimeters to kilometers or from kilometers to centimeters. 3. The third one, the components in bracket parts, the component of parts of a ratio can never be equal to 0. That means for any ratio, none of the components can be equal to 0. We go now to the fourth point, which says the components in bracket parts are compared. Still making use of the example of 10 oranges being shared to 2 persons. If the first person takes 2 oranges and the second person takes 8 oranges, it is already a comparison of 2 and 8. Now let's take down this small paragraph. When writing down ratios, we make use of the sign. Two dots as such, like this, which stands for I'll put it in quotes, 2. That means we are comparing a way of comparison to separate. Put this in bracket. It stands for 2, which is a way of comparison to separate the components of the ratio. Separate the components in bracket parts of the ratio. E.g., example given, 2:3 as a ratio is, so 2:3 as a ratio, it is simply written as 2, then 2 dots, write down 3 as such. Also, ratios can be expressed as fractions. We can also express ratios as fractions, especially when the ratio is to be simplified, in bracket, expressed in its simplest form. Close the bracket with the components, that is the components of the ratio, components of the ratio having an HCF highest common factor of 1. That means the components of the ratio, they are relatively prime. That's how we are going to say it. E.g., example given, if we take for example the ratio 6:9, we can express this ratio in the simplest form. And for us to express this ratio in the simplest form, first thing we are going to start by writing the ratio as a fraction. And writing this ratio as a fraction, the first number 6 is the numerator, and the second number 9 is the denominator. This will be equal to 6 over 9, which is equal to, in this case, we make use of the fractional form only when the ratio has two components. In a case where the ratio has 3 or more components, we cannot make use of this method of expressing the ratio as a fraction. Now, looking at the numerator and the denominator of this fraction, you will see that the highest common factor of 6 and 9 is 3. We are going to divide the numerator 6 by 3 and the denominator 9 by 3. This will simply be equal to 6 divided by 3 gives us 2 all over 9 divided by 3 gives us 3. So in the simplest form, we are going to obtain 2/3. 2 and 3, the highest common factor is 1. That means they are relatively prime. The fraction 2/3 as a ratio is simply equal to 2:3. This is for the first one. If we take the second one, 2i, if we take the ratio 2:8:10, for us to express this ratio in the simplest form, first thing we are going to start by finding the HCF of the components of this ratio, the HCF of 2, 8, and 10. The highest common factor is simply equal to 2. We are going to divide the three components of this ratio by 2. 2 divided by 2 is 2. 8 divided by 2 is 2. 10 divided by 2, like this. This will simply be equal to 2 divided by 2 gives us 1, is to 8 divided by 2 gives us 4, is to 10 divided by 2, which gives us 5. In the simplest form, the ratio 2:8:10 is simply equal to 1:4:5. Now let's take some examples on handling ratios. Take this down. Examples. These are questions. Question 1. It says express 12 days to 4 weeks as a ratio in its simplest form. We are comparing 12 days to 4 weeks. Take solution. For us to answer this problem, days and weeks, they are all units of measuring time, but they are different units. For us to easily express this ratio in the simplest form, we are either going to change the days to weeks or change the weeks to days. The units must be the same. It is very easy for us to change from weeks to days. We are going to convert the 4 weeks to days. First, we know 1 week is equal to 7 days. Then 4 weeks, if you take 4 times 1 week, which is 4 weeks, will be equal to 4 times 7 days. There is a video I did on measurements, units of measurements, how to change from one unit to the other. You can check that video you watch. This will simply be equal to 4 times 7, which is 28. Gives us 28 days. Now, if we take 12 days to 4 weeks, we're going to make use of the 2 dots, which stands for 2. 4 weeks. It will simply be equal to 12 days to 28 days. And this will simply be equal to, since the ratio has just 2 components, we are going to write it in the fractional form. The first component becomes the numerator, 12 days, all over. The second component becomes the denominator, 28 days. The unit will cancel the days. This will strike off this. This will be equal to the HCF of 12 and 28 is 4. 12 divided by 4 gives us 3 all over. 28 divided by 4 gives us 7. 3 over 7 as a ratio is simply 3 is to 7. This is the final answer when we express the ratio 12 days is to 4 weeks in its simplest form. We go now to the next example, example 2. Example 2 says express 150 centimeters to 25 meters as a ratio in its simplest form. We take solution. You see centimeters and meters, they are all units of measuring distance. They are not the same. So for us to easily express this ratio in the simplest form, we are going to change the centimeters to meters, or we change meters to centimeters. It's very easy for us to change from meters to centimeters. We know 1 meter is equal to 100 centimeters. Then 25 meters will be equal to 25 times 100 centimeters. And this will simply be equal to 2500 centimeters. For the given problem, we have 150 centimeters to 25 meters. It will simply be the same as 150 centimeters to 25 meters is 2500 centimeters. And this will be equal to, we are going to express this ratio in the fractional form. The first component will simply be the numerator, 150 centimeters all over. The second component, which is the denominator, 2500 centimeters. The centimeters will strike off, zeros will go, 1 0 will strike off, 1 0 at the denominator. The highest common factor of 15 and 250 is 5. 15 divided by 5 gives us 3 all over. 250 divided by 5 gives us 50. The highest common factor of 3 and 50 is 1. They are relatively prime. Now we can write it down as a ratio. This will be equal to 3:50. We underline the final answer. Therefore, the ratio 150 centimeters is to 25 meters in its simplest form is simply 3:50. That's what it means. We take now the next example, example 3, which says express 800 centimeters cube to 1 liter as a ratio in its simplest form. Take solution. Centimeters cube and liter, they are all units of measuring volume. Now let's answer the question. We know 1 liter is equal to 1000 centimeters cube. There's a video where I did all these conventions, how to convert from liters to centimeters cube, decimeters cube, milliliters, and so on. You can watch that video. You will learn so much from it. If we take the given problem, 800 centimeters cube to 1 liter will simply be equal to 800 centimeters cube to 1 liter, which is 1000 centimeters cube. And this will simply be equal to 800 centimeters cube all over 1000 centimeters cube. The centimeters cube will strike off. The 2 zeros at the numerator will strike off 2 zeros at the denominator. The highest common factor of 8 and 10 is 2. 2 will go into 8 4 times. 2 will go into 10 5 times. The numbers 4 and 5, they are relatively prime. That means the highest common factor is 1. In this case, we are going to express the fraction 4 over 5 as a ratio. This will simply be equal to 4:5. Such. Therefore, 800 centimeters cube to 1 liter as a ratio is 4:5. If in case you have any worries on how to express a given ratio in its simplest form, you leave your questions at the comment section. In our next video, we are going to treat equivalent ratios and problems involving ratios. You will learn so much from our next video. Please, if you like the video, share and subscribe to this channel. Thank you very much for watching.